What's up, everyone? Welcome back. Patrick here. Moving on to the next question. What we have to do is take each of these equations here. We have to find the value of x. So this is a pretty unique kind of question. We haven't done something like this yet. So starting off with part A, we got x to the negative 4 is equal to 1 over 16. So basically, what value of x would give us this right here? And with these kinds of questions, what I recommend doing, there's actually different ways to do it. Your teacher may show different ways. The way that I recommend doing is using exponential rules to take the side that has all numbers, that doesn't have the variable on the side. So notice the left side in this case has the variable. So take the right side and try to put it in this kind of format over here. And then if we can get the same format, then we could clearly see what the x value is going to be. And so the way you can do that here is notice that the 16 we can rewrite as 1 over 2 to the power of 4, like that. We can also rewrite it as 4 to the power of 2, so we could rewrite it as 1 over 4 to the power of 2. And sometimes this takes a little bit of trial and error. Sometimes you got to sort of work through these problems, but the problem here is that the exponent is a 2, and over here we have an exponent of negative 4. So even if we bring this up, it would be 4 to the negative 2. Notice that this exponent and this exponent, they're not the same thing, right? Versus here, 2 to the power of 4, notice we have an exponent of 4. So what we can do is we can now take this, bring it up. We know when we bring it up, it's going to be a negative exponent now, right? This and this are the same thing. And now notice that the right side is the same format as the left side, right? So it's almost like a puzzle. There's not too much like math involved. You're just trying to take this, the right side, and make it the same format as the left side. So sometimes it'll take a little bit of time to play around with it because sometimes you can get more complex stuff, especially when you're working with like fractions, like we're gonna do in a sec. But for this particular question, for part A, this is how I would do it. And then from here, x to the negative 4 equals 2 to the negative 4. Well, it's obvious to see that the x value is just 2. And so that's what the answer would be for part A. And then just to double check, you could take your answer and you could just plug it in. 2 to the negative 4 would equal 1 over 2 to the power positive 4, which would be 1 over 16, which is what that right side is right there. So you could always double check your answer by plugging it back into the original and seeing if you get the left side equaling the right side. Now in part B, we have x to the negative 1 equals 6 over 7. So the question here is, how can we take this right side and make it be something to the power of negative 1? Because if we can take this and convert it to this format, well then whatever that something is in the bracket, that's going to be the x value, right? So we've got to try to take this, put it in this kind of format. Well, what we can do, just in general actually, let me just do a quick review. If we have a fraction to a negative exponent, that's the same as taking the fraction and flipping it, and then making the exponent positive. So what we can do with this is, because the exponent is negative 1, why don't we just make this, for now, be 6 over 7 to the power of positive 1. So notice that this is in this kind of format over here, right? Because anything is the same as that thing to the power of 1. So we could rewrite the 6 over 7 as to the power of positive 1. And then what we could do is we could flip it, so we would go from here to here. We could flip the fraction and then change the exponent to be a -1, like that. And now notice the right side is in that same format as the left side. And so from here, the x value, it's obvious to see, it's just this bracket, 7/6. Right? So in this case, x is just equal to 7/6. Right? 7/6 to the power -1 is the fraction flipped over, 6/7 to the power +1. Right? Which would give us that right side right there. So again, you could take this, plug it in here, see with the algebra if you would end up getting that right side. Right? So that's the answer for part B. Over here in part C, we got 3 to the power of x equals 1/81. Well, notice that we can take the 81, rewrite it as 3 to the power of 4, like that. And then the 3 to the power of 4, notice that over here we have 3 to the power of something. So we can't just keep this 3 to the power of something in the denominator, we got to bring it up. And now notice that it's in the format because we have the same bases, so we could just drop the bases. X is just -4. Right, so it just takes a little bit of playing around with that right side and getting it to that format. And again, if we want to check our answer, 3 to the -4 equals 1/3 to the power +4, which is 1/81, like that. Okay, so moving on to part D. What do we got? We got 2/3 to the power of x equals 27/8. Now this one's going to be a little bit more tricky. Notice that the fraction, the base, the exponent, is 2/3 versus over here we have 27/8. But notice that the 27, we can actually rewrite that as 3 to the power of 3. And then the 8 we can rewrite as 2 to the power of 3. So we don't have a fraction here yet, but notice that now we're working with 3 and 2, and we have a 2 and 3 here as well. Right? It's not in the same format yet, but we're getting closer and closer. Now, just in general, if you have a fraction to an exponent, that's equal to the numerator to that exponent over the denominator to that exponent. You could take that exponent and distribute it, quote unquote, to the numerator and denominator. And so notice in this case, what we can do, because both of these have the same exponent, the numerator and denominator, so it's in this kind of format, where the a is like the 3, the x is the 3, and then the b is like the 2. We have that same exponent. We could take it out of the numerator and denominator. And so we could rewrite this as 3/2 to the power of 3, like that. And notice now we are getting much and much closer to that format of 2/3 to the power of x. And what's the only thing remaining? Well, here we have a base of 2/3, here we have a base of 3/2. So what we can do is we can actually, let's continue this over here, we'd have 2/3 to the power of x. What we can do to change this 3/2 to be 2/3 is we could flip the base, the fraction base, but if we do that, we got to change the exponent to a negative, like that. And then from here, same base, we could tell x is just equal to -3. So that ends up being the answer for part D. And again, you could take your answer, do a quick check. So let's do 2/3 to the power of that x value that we got of -3. How would we solve this? Well, we would flip the fraction, change the exponent to a positive. Then we could take the numerator to that exponent. We could take the denominator to that exponent. We'd end up with 27/8, which is that right side. All right, so again, just some trial and error, just some playing around with it. Many times you may not get it as fast as we're getting it now, but just take your time with it and see what you can come up with in order to make that left side equal to the right side. And then finally we have, let's write it over here, 5 times 3 to the power 2x equals 45. Now, what I recommend doing in this case is, because this 5 here is by itself and we're multiplying it by this exponential expression, why don't we just bring the 5 over? And the way we could do that is we could just divide both sides by 5. So we could just completely get rid of it, and notice that 45 divided by 5 gives us a smooth number of 9. And so we just end up with 3 to the power of 2x is equal to 9. And in my opinion, working with this is much easier than working with that right there. Right? You're not always going to have the opportunity, but if you do, if you just see something by itself like this, you could just divide both sides by that number. And then you'd end up with an exponential expression equaling something. Just a single exponential expression without anything in front of it, like we had here. Notice that we had just single exponential expressions always on the left side, versus here we had something in front of it, right? So we divided both sides by that. Or let's say it was maybe like we're adding something. Let's say it was like 5 plus 3 to the power 2x is equal to 45. Right? We could bring the 5 over. The way we would bring that over is we would minus it now because it's adding here. So we'd have 45 minus 5, and we'd end up with 40 on the right side. But then you wouldn't actually be able to solve this here without a calculator, unless you did a bunch of trial and error, because the x value would be some kind of decimal, right? Because you can't rewrite 40 as 3 to the power of something. But the 9, in this case, you can rewrite this as what? 3 to the power of 2, like that, right? 9 is the same as 3 to the power 2. And notice we have it in this format now. We could drop the bases because we have 3 to the power of something equals 3 to the power of something, which means that both of those exponents have to be the same. And then from here, just divide both sides by 2, so x is just equal to 1. So that ends up being the answer to part E. And then again, if you have time, if this is on a test, you could check your answer, plug in 1 here. 2 times 1 is 2. You got to do the exponent first before multiplying. So you go 3 to the power of 2, which is 9. 9 times 5 gives us 45. Right? So with these kinds of questions, that's the way that I personally would do it. It's more like a puzzle. As I said, what you got to do is you got to try to get both sides to be in the same format. And then from there, what you can do is once they're in the same format, you could see what that variable is equal to.